Hello everyone, we are group number 35 and our project was forecasting household power consumption using hybrid LSTM and CNN model. The problem statement was to accurately predict household energy demand using historical energy consumption data, and we integrated weather data to address the fluctuation caused by energy external factors. Our dataset used was individual household electric power consumption dataset by UCI. It was a 4 years of minute by minute power consumption data, and the features include voltage, current, power factors, and submetering values. We integrated weather data using the OpenMeteo API for the Paris for the same time frame. It was an hourly temperature, humidity, precipitation, and wind speed. We use linear interpolation to match the minute level consumption data. For the baseline comparison, we used linear regression model. The mean squared error and mean absolute error was 0.29 and 0.39. So this suggests that the dataset is complex and a simple linear regression model could not betterly predict the values for the dataset. Let's move over to the network architecture of our hybrid LSTM and CNN model.
So for our proposed model, the input layer consists of multidimensional time series data. So this data has the power consumption data of the household plus the weather information during that time. So it turns out to be we have decided to use 8 features which are concatenated over 168 hours. That is 1 week of the 1 week. Now second layer is our CNN component. We chose to use CNN because CNN layers are known to extract spatial features from the input data, and it also captures the local patterns and relationships between different features. And we also used pooling layers to reduce the dimensionality while preserving important features. Secondly, we then follow it up with an LSTM component. We decided to use LSTM because it can capture temporal dependencies, especially in a sequence data like the time series data set which we are using. And LSTM is also good at learning long-term dependencies within the consumption patterns. And then finally we follow it up with dense layers which is basically a fully connected layer for the final prediction, plus some dropout layers in order to prevent overfitting. And then finally in the output layer we predict the future power consumption for the household in the next 1 hour. And this is the architecture of our proposed model. Initially we have a input layer with 168 into 8 size. Then we follow it up with 2 convolutional layers of this given output shapes. And then we follow it up with 2 LSTM layers. And finally a dense layer to predict the output, which is the power consumption for the next 1 hour. Now let's discuss the evaluation of our model.
So, based on our LSTM hybrid CNN model, the evaluation plan and results are as follows. So, for validation, we have used time series cross validation with rolling window, in which a fixed size window will be used as validation and will be rolled over across the database data set. And in for hyperparameters tuning, we have used grid search, which will try out all the possible combinations of hyperparameters and get use the hyperparameters with better results. And for error metrics, we have used mean square error, penalizing the larger error values. So the results obtained for our models are as follows. So the mean square error reduced from 0.3 to 0.0097, which is great. And similar results were seen in mean absolute error as well. And as you can see, this is the training model loss across epoch levels. We had higher loss in the beginning epochs, and that have been reduced quite further down. And this is our prediction values for a forecasting model. So the true values are represented by blue, and orange shows the predicted values for from our model. So as you can see, the graphs are matching to based of it's fitting based to the true values, showing our model's accuracy. And we have also attached the reference links that we have used. This is the dataset link for OpenMeteo API as well. And thanks everyone.